Hi everyone, welcome back to this channel. I am Timothy from Cognito Academy. In this video, we will be covering physical quantity, units, and measurements. So let's hop into it. Physical quantity, like the mass of an object, is the quantity of the object that we can measure. A physical quantity like mass is represented by a magnitude and a unit, like 10 kilograms, where 10 is the magnitude and kilogram is the unit. There are two types of physical quantities, base quantities and derived quantities. Let's touch on base quantities first, which are fundamental physical quantities that are not defined in terms of other quantities. In layman terms, they are the most basic quantities, and there are 7 types of base quantities. And the 5 base quantities you need to know are length, mass, time, temperature, and current. You also need to know their respective SI unit associated to them, namely meters for length, kilograms for mass, seconds for time, Kelvin for temperature, and ampere for current. So we have touched on base quantities, which are the most basic quantities like length and mass. They are not made out of other quantities. The other classification of physical quantity is derived quantity, that is derived by combining various base quantities. For example, volume, which is derived by multiplying 3 measurements of length, namely the length, breadth, and height of an object. Another derived quantity is speed, which is distance divided by time. So as we can see, these derived quantities are derived by combining various base quantities. Now, I want to introduce the concept of prefixes. Prefixes are preceding factors which acts as a multiplier to a unit. In simple terms, a prefix is something that you put in front of a unit that multiplies that unit. Let's take a look at kilometer. It is made out of the prefix which is kilo, and is in front of the base unit meter. Kilo refers to 10 to the power of 3, so kilometer simply refers to 1000 meters. The benefits of prefixes are more apparent with extremely small or large quantities. Say we are measuring a very small fraction of time of 0.000001 second. But instead of repeating so many zeros, we can simplify this to its standard form, 10 to the power of negative 6. And in terms of naming, we name this 10 to the power of negative 6 as micro, meaning we can call this a microsecond. And this micro term is the prefix, which comes before the unit second. And this is how we simplify the naming of very small or large quantities, by using prefixes. Here are the list of prefixes going from the smallest, nano, micro, milli, centi, deci, to the prefixes that are above 1, kilo, mega, and giga. You have to memorize these prefixes along with their respective magnitudes. We have learned the 2 types of physical quantities and the concept of prefixes. Now, let's learn how to actually measure some of these physical quantities. The first we will touch on is the measurement of length. We have several instruments to measure length, the common ones being ruler, vernier caliper, and micrometer screw gauge. A property of this instrument is their precision, meaning the smallest unit the instruments can measure. Like for example, the smallest unit in a ruler is 1 mm, meaning that is the most precise the ruler can get, and we say the ruler has a precision of 1 mm. The ruler is meant for measuring relatively larger objects, within the range of several centimeters to a meter. For measuring smaller objects to a greater precision, we use the vernier caliper or the micrometer screw gauge. The vernier caliper is suited for measuring objects within 1 and 15 centimeters, and it has a higher precision of 0.1 mm, a decimal place more than the ruler. The micrometer screw gauge measures even smaller objects of length less than 2.5 centimeters, with an even higher precision of 0.01 mm, 1 decimal place more than that of the vernier caliper. When reading length or volume, common experimental error is parallax error, which occurs when the recorded reading deviates from the true reading due to our eyes being positioned at an angle to the measurement markings. To prevent parallax error, place your eye directly at the level of the appropriate measurement marking when measuring, say, the length of the wooden plank or the level of a liquid in a graduated cylinder. We have learned how to measure length. So now let's learn how to measure time. We typically use a stopwatch, and a typical stopwatch might have a precision of up to 3 decimal places of a second. But we will only take readings to the nearest 1 decimal place, which for this case 30.9 seconds. This to account for the random error introduced due to human reaction time. Now let's learn how to find the duration of a period of a pendulum. A period is defined as the time taken for one complete cycle, for the pendulum to make one full back and forth swing, which comprises of a left swing and a right swing. To find the duration of a period, we will record the duration for 20 periods, and then divide this measured time by 20 to get a duration of 1 period. By doing this, we reduce the percentage error due to human reaction time by a factor of 20. To further improve on the accuracy of this experiment, we can take multiple readings for our 20 periods, and take the average duration for these 20 periods before dividing by 20 to get the duration of a period. With that, this wraps up our video on physical quantities, units and measurements. If you found this video helpful, we would really appreciate if you can like and subscribe to our channel. Also, do visit our Instagram page and website. Links are down below. With that, see you soon.